Alright guys, today we're learning about the law of cosines. So I want to talk about what it is and when and how to apply it. So what the law of cosines is, it's basically, you think about it like this, that's the Pythagorean theorem. So it's essentially the only new part is that. It's just something that you add on to the Pythagorean theorem. The easy way to remember it, remember it follows the Pythagorean theorem pattern. And then the how to remember this last part is this is an angle C, and that's a side length C. So your C's are on the outside, your A's and your B's are on the inside here. And so like variables on the outside, like variables on the inside, with a 2 out front. So here are the two situations where you would end up using the law of cosines. And basically what you'll notice, as I was talking about the other day, with the law of sines, you're looking for something like that. And in this case, there is no side length here. There's no way to find it. So you have to use the law of cosines. Likewise, in this situation, there is no angle measure there, and there's no way to find it based on what you know. So therefore, you're stuck using the law of cosines. One thing to keep in mind when you're using the law of cosines, you should always use the law of cosines. If you're finding an angle measure here, that has to be the biggest angle. So make sure you're finding the largest angle or the biggest angle measure. And we'll talk more about it in class, but it makes your life a lot easier if you find the largest angle measure with the law of cosines. Alright, so here is the law of cosines and all of its different versions or iterations. You don't have to memorize all of these. Just keep in mind that's the side situation here. All of those are is just these equations here to the left, but then you just solve for the cosine. Like that's it. So if you don't have to memorize everything, if you just remember this one and then solve it for what you need to solve for here, you don't have to do all the extra memorizing. Okay, so let's go through our examples here. So we want to find remaining angles and side lengths. So what I'm looking for first, angle measure I'm given, not given the opposite side, so I know for sure I'm using the law of cosines. So this means that this is C, right? Because it's the side length opposite of C. So C squared is going to equal the other two side lengths squared. So the sum of the other two side lengths squared minus 2. And then, like I said, the easy way to remember it is these inside numbers just repeat again. So minus 2 times 14 times 10 times the cosine of C, because it's C out here. So angle C is 60 degrees. Okay, so then we start plugging it in. So C squared is going to equal, 14 squared plus 10 squared is 296 minus 2 times 14 times 10 times the cosine of 60 minus 140. So then 296 minus 140 gives us 156. Square root both sides, and we end up with 12.49. Okay, so we found this to be 12.49. Now, instead of redoing the law of cosines again to find the other stuff, at this point we're going to use the law of sines. Now, with these types of problems, it's typically best to use the law of sines first to find the smallest angle measure. So that would be angle A. So I'm going to have the sine of A over 10 equals, now, since I found the opposite side of 60, I'm going to reuse that in this problem. So sine of 60 over the 12.49 So when you cross multiply and solve, you will end up 43.90, it looks like. 43.90. Okay, and then to find the last one, you have these two angle measures now. Oops, 43.90. Since you have these two angle measures, you just subtract them from 180 and end up with a 76.10. That's it. There's your law of cosines. Alright, here's the next one. Same concept again here. We're missing that side length B. We need it so that we can then set up our law of sines. So we're going to have B squared equals the sum of the other two side lengths squared. So 21.5 squared plus 17.2 squared minus 2 times 21.5 times 17.2 times the cosine of 98.1. Throw it all in a calculator. You should have that B squared will equal 862.3, which when we square root both sides, B comes out to equal 29.36. Alright, so we have our side length. So now we're using that with the law of sines. So 98.1 over 29.36 will equal, and we want to find the smallest angle measure first, so it's opposite the smallest side. So sine of A over 17.2. When you cross multiply and solve, you will end up with angle A equaling 35.45 degrees. Okay, so on the last one, you take 180 minus your 35.45 minus your 98.1, and you will end up with 46.45 again. Alright, so there's our answers. So those are the first two, like I said, where you have an angle measure and the two side lengths. So in this case now, let's look at one where you're not given any angle measures. So if I'm not given any angle measures, what I want to do is I want to solve for the biggest angle measure first, which means I want to incorporate the biggest side length. So when I'm solving this, since the C, I'm trying to solve for angle C, that means the C values go on the outside. So then on the inside is a 14 squared plus 11 squared minus 2 times 14 times 11 times the cosine of angle C. So I want to solve all of this. So I want to find what 17 squared is. So that's like 289. 14 squared comes out to 196. 11 squared is 121. 196. 121 minus our 2 times our 14 times 11 is 308 cosine of C. Now one thing where people will make a lot of mistakes with this is that when they start working on the right hand side of the equation, they don't realize that they can only combine those two that I've marked in red, because this has a variable attached to it, so it has to be done separately. So to solve this, I'm going to take 196 plus 121, and that comes out to be 317 minus 308 cosine of C. Okay. So then we minus our 317. Once again, not combining it with the cosine, because that is bad. Negative 28 equals negative 308 cosine of C. Negative 308. And that will give us 0.091 equals the cosine of C. So then we take the cosine inverse. C equals 84.78 degrees. So now that we have that, now we're using the law of sines for the rest of this. So I'm going to have the sine of 84.78 or 17 equal, we still want to find the smallest first. So then that gives me the sine of A over 11. When I cross multiply and solve, I end up with A equaling 40.19 degrees. So then I take that 180 minus that answer minus my 84.78, and my last answer I end up with 55.10. So that's how you would use the law of cosines for a problem with no angle measures given. That concludes this. So we're out of time. We'll do this one in class. And then here's some extra practice problems. If you want them, I'll give out the worksheets tomorrow in class. Otherwise, hope this makes sense. See you later.